What are inverse operations in algebra? Explained simply. Imagine trying to solve a mystery where each step you take to uncover the answer can be undone just as easily. That's what inverse operations do in algebra. They are like undoing a puzzle piece to get back to where you started. In algebra, inverse operations are pairs of actions that reverse each other. The most common ones are addition and subtraction, and multiplication and division. Think about adding 5 to a number and then subtracting 5. You end up right back where you began. That's because addition and subtraction are inverse actions. They cancel each other out. The same idea applies to multiplication and division. If you multiply a number by 3 and then divide by 3, you get your original number again. This relationship is super helpful when solving equations. For example, if you have an equation like 2 times a number plus 3 equals 17, you can use inverse operations to find that number. First, you subtract 3 from both sides to undo the plus 3. Then, you divide both sides by 2 to undo the multiplication. This process helps you isolate the variable, which is the unknown number you are solving for. There are special names for these inverse actions. The additive inverse of any number is its negative. For example, the additive inverse of 5 is negative 5 because 5 plus negative 5 equals 0. 0 is the identity element for addition, meaning adding 0 to any number doesn't change it. The multiplicative inverse of any non-zero number is its reciprocal. For example, the reciprocal of 4 is 1 divided by 4 because 4 times 1 divided by 4 equals 1. 1 is the identity element for multiplication, so multiplying any number by 1 doesn't change it. Using inverse operations in algebra is like having a set of tools that help you reverse steps. If you multiply first and then add, you undo the addition first by subtracting, then undo the multiplication by dividing. This step-by-step process makes solving linear equations easier and more straightforward. Understanding inverse operations helps you see how to work backwards in an equation. It makes solving 4 unknowns less confusing and more logical. When you learn how to use these inverse actions, algebra becomes less about memorizing and more about understanding how to reverse each step to find the answer. This approach turns complex problems into simple, manageable steps that you can follow with confidence.